Okay, number 8. Number 8 involves the chain rule. So the first example is f of x equal to e to the secant of x. And let's recall that the chain rule says if we have two functions composed, f of g of x, then its derivative is given by the derivative of the outer function applied to the inner function, f prime of g of x, times the derivative of the inner function, which is g prime of x. So we take the derivative of the outer guy, leave the inner guy alone, then we multiply by the derivative of the inner guy. So when I take the derivative here, the outer guy is e to the x. This is e to the x on the outside. The inside function is secant of x. So we're plugging secant of x into e to the x. So the derivative of e to the x is itself. So when I take the derivative of e to the x and apply it to the inside function secant of x, I get e to the secant of x. Nothing crazy happens there. Okay, then I multiply by the derivative of the inside function. My inside function is secant, so I multiply by its derivative, which is secant times tangent, or tangent times secant. It's equivalent, doesn't matter. Multiplication is commutative. So secant tangent, that's my final answer. Again, this is the derivative of e to the x applied to secant of x times the derivative of secant of x. B is more work because we have a composition of three functions. I have arctangent of the natural logarithm of x squared. All right. So what happens here is if I've got three functions, f of g of h, when I take its derivative, it's going to look like this. Its derivative is I take the derivative of the outer guy. What is that? I take the derivative of the outer guy and I leave the inner two guys alone. Then I take the derivative of the middle guy and I leave the innermost guy alone. Then I take the derivative of the innermost guy and I multiply those all together. So f prime evaluated at g of h times g prime evaluated at h times h prime. So the outermost function is arctangent. Its derivative is 1 over 1 plus x squared. When I evaluate that at the natural logarithm of x squared, I get 1 over 1 plus the natural logarithm of x squared, quantity squared. So that entire thing gets squared. Now I take the derivative of the middle guy, which is log of x, and I evaluate that at the inside function. So the derivative of log of x is 1 over x. Applying that to x squared, I get 1 over x squared. Great. Finally, I have to multiply by the derivative of the innermost guy, which is x squared. Its derivative is 2x. Note that I really could have done the derivative of log of x squared in one fell swoop by recognizing that it's the logarithmic derivative. It's the derivative of x squared over x squared, but whatever, I parsed it out carefully. Yeah, so this is our final answer. Great.